The EPR Paradox. Look at your hands. Look at the screen in front of you. They feel solid, real, definite. You are here and I am there. This is the universe as we know it. The universe of common sense. A universe of separate objects, of clear locations, of a single, unchangeable past. But what if I told you that this reality, this comforting solidity, is a magnificent illusion, a shimmering hologram projected from a deeper, weirder, and infinitely more connected layer of existence? What if, at the very heart of everything, lies a magic so profound that it defies space and time itself? Today, we are diving into one of the greatest mysteries ever conceived by the human mind. An idea so bizarre, it was dismissed as spooky by its own creator, the great Albert Einstein. This is the story of the EPR Paradox, a story not of a single particle, but of a ghostly connection that binds the cosmos into one inseparable whole. To understand the magic, we must first set the stage. We must travel to the dawn of the 20th century, to the birth of quantum mechanics. The physicists of this era were like explorers who had stumbled into a realm of pure enchantment. In this subatomic world, the rules of our everyday reality simply vanished. Particles weren't just tiny balls. They were phantoms. They could be in multiple places at once, a phenomenon called superposition. Think of it not as a scientific term, but as a state of pure potential. An electron is not here or there until you, the observer, look at it. It is a shimmering cloud of here-ness and there-ness, a cosmic dice yet to be rolled. The very act of observation, of measurement, forces this phantom to choose a single, definite reality. It's as if the universe itself is waiting for a conscious mind to ask a question before it decides on an answer. This drove Einstein absolutely mad. For him, God did not play dice with the universe. The idea that reality was fundamentally random, that it depended on someone looking at it, was an affront to the elegant, clockwork cosmos he believed in. He was a firm believer in local realism. Let's break that down. Realism means that things have definite properties, whether we measure them or not. The moon is there, with a definite location, even when no one is looking at it. It's real. Locality means that no influence, no signal, no information can travel faster than the speed of light. It's the universe's ultimate speed limit. Nothing can affect anything else instantaneously across a distance. To Einstein, this was just plain common sense. But quantum mechanics was screaming that both of these ideas were wrong. So, in 1935, with his colleagues Boris Podolsky and Nathan Rosen, Einstein devised a thought experiment, a paradox, designed to show how utterly absurd quantum theory had become. It was a weapon, forged in the fires of logic, to slay the quantum dragon. He intended to prove that the quantum description of reality was incomplete. Little did he know, he was about to accidentally reveal the universe's deepest, most magical secret. Imagine, if you will, a single, unstable particle. It has no charge, no spin, it's a blank slate. And then, in a flash of energy, it vanishes. But from its death, two new particles are born, an electron and a positron, flying away from each other at incredible speeds. Now, according to the quantum rules that Einstein hated, these two particles are entangled. They are not two separate entities. They are one single, unified quantum system. They are like two sides of the same cosmic coin, born from the same initial spark. And here is the magic. Let's say these two particles have a property called spin. It's not like a spinning top, but think of it as an intrinsic arrow pointing up or down. But remember superposition? Before we measure it, the arrow of each particle is both pointing up and down simultaneously. It's a blur of all possibilities. The entanglement means their fates are linked. The quantum rule says, if one particle is found to have spin up, the other must instantaneously be found to have spin down. It's a perfect, mirrored correlation. They are yin and yang, forever bound by an invisible thread. Now let's make this truly mind-bending. Let these two particles fly apart for light years. They become separated by an unimaginable gulf of space. Empty voids, nebulas, entire star systems now lie between them. You, as a cosmic scientist, set up a detector for one of the particles. Let's call it Alice. You catch particle Alice and you measure its spin. The dice roll, the phantom collapses, and you see spin up. At that exact moment, instantaneously, across light years of emptiness, particle Bob knows. Its own blur of potential vanishes, and it snaps into a definite state of spin down. How does particle Bob know? What is the signal? How does the message travel from Alice to Bob faster than light, seemingly in zero time? Einstein called this spooky action at a distance, and for him, it was proof that quantum mechanics was nonsense. His reasoning was brilliant. He said, there are only two possibilities. One, the moment you measure Alice, you send some kind of magical, faster-than-light signal to Bob, telling it which state to choose. This violates locality, the universal speed limit. It's impossible. Or two, and this is what Einstein believed was the real answer, the particles are not truly random. They are like a pair of magical gloves. You have a left glove and a right glove. You put them in two boxes without looking and send them to opposite ends of the Earth. The moment you open your box in New York and see a left-handed glove, you know, with absolute certainty that the box in Tokyo contains a right-handed glove. There's no spooky action. The gloves were always left and right from the moment they were created. They had hidden variables, secret instructions that determined their fate all along. Einstein's argument was a masterpiece of common sense. The particles seem random, but they are just carrying a hidden plan. There is no spookiness. Reality is local and real. The moon is there when we aren't looking, and no signal breaks light speed. For decades, this was a philosophical debate, a war of ideas between giants. Einstein and his common sense versus the quantum pioneers like Niels Bohr, who embraced the weirdness. Bohr's response was essentially, your common sense is the problem, Albert. The universe is not obliged to make sense to you. The connection is real. The spookiness is a feature, not a bug. The debate was deadlocked. It was pure metaphysics, until a brilliant Irish physicist named John Stuart Bell came along. In the 1960s, Bell found a way to translate this philosophical war into a real, tangible experiment. He devised a mathematical theorem, a cosmic judge, that could, in principle, decide who was right. He created a test. The logic was exquisite. If Einstein was right and hidden variables determined everything, then the correlations between the particles would follow one set of statistical rules. If Bohr was right and the spooky, instantaneous connection was real, they would follow another. For years, it remained a thought experiment. The technology didn't exist. But then, it did. In the 1970s and 80s, physicists like Alain Aspect performed the experiment. They created pairs of entangled photons, particles of light, and set them flying in opposite directions. They built detectors that could measure their properties randomly and incredibly fast, ensuring no normal light speed signal could possibly travel between them. The universe was put on trial. On one side, the ghost of Einstein and his steadfast belief in a sane, local, real world. On the other, the bizarre, phantom-like world of quantum theory. The results were clear, unambiguous, and they shook the foundations of physics to its core. Bohr was right. Einstein was wrong. The correlations between the particles violated the rules for hidden variables. They matched the predictions of quantum mechanics perfectly. The connection was instantaneous. The spooky action was real. Think about what this means. It means that when you measure one particle, its twin, light years away, responds instantly, not almost instantly, not very, very fast, instantly, as if the vast distance between them does not exist, as if space itself is an illusion. This isn't a theory. It's a laboratory-verified fact, repeated countless times. We now use entangled particles in emerging technologies like quantum cryptography and quantum computing. The magic is becoming engineering. So what is actually happening? How can we possibly understand this? The answer is that we can't, not with our everyday logic. Our minds are wired for a world of separate objects. But the universe, at its fundamental level, is not separate. It is non-local. Imagine the cosmos as a vast cosmic ocean. We are like waves on the surface, each appearing separate and distinct. You are a wave here, I am a wave there. But beneath the surface, we are all part of the same, inseparable body of water. The entangled particles are like two ripples that arose from the same splash. They are not two things sending signals. They are one single phenomenon, manifesting in two different locations. The separation is the illusion. Or, think of the universe as a hologram. In a hologram, every single piece contains the information of the whole. If you break a holographic plate, each shard still shows the entire image, just from a different perspective. What if every particle in the universe is a shard of a single primordial cosmic hologram? What if your body, the screen you're watching on, the most distant star, are all, in some deep and fundamental way, one? This is the mystical truth that the EPR Paradox points towards. It's a truth that echoes in ancient spiritual traditions, the idea of an underlying unity, a Brahman, a Tao, a connection that transcends the illusion of separation. The particles are not communicating. They are simply one. Your observation here doesn't cause a change over there. Your observation here is the change over there, because here and there are, in the quantum realm, meaningless concepts. This forces us to ask terrifying, wonderful questions. Is the entire universe a single, massively entangled system? Was everything that exists today linked in a primal embrace at the moment of the Big Bang? Are we right now still ghostly connected to every other thing in the cosmos? What does this say about consciousness? If the act of observation collapses possibility into reality, what role do we, the observers, play in weaving the tapestry of the cosmos? Are we passive witnesses, or are we active participants in the creation of reality itself? The EPR Paradox began as an argument to restore sanity to the universe. Instead, it opened a doorway to a reality far more magical, more interconnected, and more mystically profound than Einstein could have ever imagined. He sought to kill the spook, and instead, he gave it a name and proved it was real. We are not solitary beings in a cold, empty space. We are knots in a cosmic net, ripples in a single quantum field, notes in a universal symphony. The space between us is filled not with emptiness, but with potential, with connection, with a spooky, magical, and beautiful unity. The journey into this mystery is just beginning, and I want to continue it with you. If your mind is reeling from these ideas, if you feel that sense of wonder, then do me a favor, like this video. It tells the YouTube algorithms that you crave more deep, cosmic content. Subscribe to the channel, because we have only scratched the surface of the quantum world, and there are so many more mysteries to explore, from parallel worlds to the holographic principle. And I want to hear from you. The implications of this are vast. What do you think this quantum connectedness means for our understanding of reality, of consciousness, of our place in the cosmos? Let's have a conversation. Comment down below with your thoughts, your theories, your own sense of awe. And if you truly want to fall down the rabbit hole, if you wish to explore a vision of a cosmos where this interconnectedness is the key to understanding everything, from the Big Bang to the nature of mind, then I invite you to check out my book, Holographic Multiverse. In it, I weave together quantum physics, cosmology, and philosophy to paint a picture of a reality that is literally made of information, a cosmic hologram of which we are all a part. The link to purchase it is in the description below. Thank you for joining me on this journey to the edge of reality. Remember, the universe is not only stranger than we imagine, it is stranger than we can imagine. Stay curious.